All right, let's talk about one of the biggest, most transformative technologies out there, artificial intelligence. We're going to go beyond just what it is and really dig into the fascinating ways these machines actually think. Let's dive in.
I mean, think about it. What if a machine could actually think? It sounds like something straight out of a movie, right? But the thing is, it's not some far-off concept anymore. It's happening all around us, every single day.
You know, every time Facebook or your photo app just knows it's you in a picture and suggests a tag, yep, that's AI. It's using computer vision to see and identify, just like our own eyes.
Or what about when you ask your phone for the weather? An AI is literally listening, figuring out what you want, and then speaking the answer right back to you.
And look, it's not just about convenience. This stuff is in the cockpit of airplanes, it's helping to drive cars. We're talking about incredibly high-stakes, complex tasks that demand perception and split-second decisions.
Okay, so we've seen it in action. But what is it, officially? Well, at its heart, artificial intelligence is all about the science and engineering of making intelligent machines. The whole goal is to build what we call intelligent agents, which is just a fancy way of saying systems that can look at their surroundings and take the smartest possible action to get something done.
But here's where it gets really interesting. There isn't just one way to build a smart machine. The whole field is actually built on 4 totally different ideas about what we're even trying to achieve.
So, this table really breaks it down. You've got 4 different schools of thought. First, do we want a machine that thinks like a human? You know, modeling our messy, creative, sometimes irrational thought processes? Or is it good enough if it just acts like a human, so well that we literally can't tell it apart from a real person? Then you have the other side of the coin. Maybe trying to be human is the wrong goal entirely. Should we be aiming for a machine that thinks rationally, using pure, cold, hard logic? Or, and this is actually the most popular approach today, should we just build something that acts rationally? Meaning, it just does whatever it needs to do to get the best possible outcome, and we don't really care how it gets there.
Okay, but that brings up a huge question, right? Especially for that acting humanly idea. How on earth do you know if you've actually succeeded? How do you test if a machine is smart enough to fool a person?
Well, that brings us to the legendary Turing test. Alan Turing came up with this way back in 1950, and it's just brilliant in its simplicity. Here's how it works. You have a person, an interrogator, sitting in a room. They're typing questions to 2 others that are totally hidden. One is another person, and the other is an AI. The whole game is for the interrogator to figure out which is which. And if they can't reliably tell the machine from the human, boom, the AI passes the test. It has successfully acted human.
Okay, so you hear all these terms flying around all the time, right? AI, machine learning, deep learning. It can sound super confusing, but honestly, the relationship between them is pretty simple. The best way to think about it is like a set of Russian nesting dolls.
So, artificial intelligence, AI. That's the biggest doll on the outside. It's the whole field, the entire grand project of trying to make machines intelligent. It's the whole shebang.
Now you open up that big AI doll, and inside you find machine learning, or ML. This isn't the only way to do AI, but it's become one of the most powerful. The big idea here is, instead of trying to write a million lines of code with explicit rules for every single possibility, you build systems that can learn patterns for themselves just by looking at tons of data.
And then, nestled inside the machine learning doll, you find the smallest one, deep learning. This is a very specific, super powerful type of machine learning that uses these really complex, layered structures. They're actually inspired by the neural networks in our own brains to learn from absolutely massive amounts of data. This is the engine that's powering so many of the crazy breakthroughs we're seeing today.
But here's a key thing to understand. Whether we're talking about the big AI doll or the tiny deep learning one, just having tons of data and a fast computer, it isn't enough. Early AI pioneers figured this out pretty quickly. To solve really hard, complex problems, these systems needed something more. They needed knowledge.
And knowledge isn't just a pile of facts. It's not just raw data. It's organized. It's context. It's this whole body of facts and principles that turns random information into something truly useful. It's what the slide calls a true justified belief.
And when we talk about building a smart system, it really comes down to 2 main kinds of knowledge. First, you've got declarative knowledge. Think of this as the what. It's a library of facts about the world. For example, Joe is tall. Simple fact. But then you also need procedural knowledge. This is the how. It's like a recipe or a set of instructions. Here are the steps to solve an equation.
A really smart AI needs both. It needs a library of facts, and it needs a playbook for how to use them. Okay, so the AI has all this knowledge stored away in what's called a knowledge base. But just having it isn't enough, right? How does it actually use it to think? How does it connect the dots?
Let's walk through a super classic example. Imagine we give an AI a simple fact. We add this to its knowledge base. Socrates is a human.
All right, pretty straightforward. Next, we give it a rule, something that tells it how different ideas are connected. Let's add this. All humans are mortal.
Okay, so the machine now has two things in its brain. A fact, Socrates is a human, and a rule, all humans are mortal. So what can it figure out?
It concludes, of course, that Socrates is mortal. And this process, this ability to draw brand new conclusions from the facts and rules it already has, that's called inference. This is the absolute core of machine reasoning. It's not just spitting back facts it was told, it's creating new, logically sound knowledge.
All right, let's do a quick recap of the most crucial points here. 1. AI is the whole science of making machines that can learn and solve problems. 2. There are different ways to do it. You can try to make them think or act, and you can aim for human-like or just purely rational. 3. The real magic isn't just data, it's a rich knowledge base. And 4. An inference engine uses that knowledge to reason and draw new conclusions, just like we saw with Socrates.
And that really brings us to the edge of what's happening right now. For decades, the whole game was about carefully teaching machines our human knowledge so they could reason with it. But the new frontier is building systems that can go out into the world and build their own knowledge from scratch. And that leaves us with a pretty mind-bending question to think about. What happens then?